So the second part of this unit is all about graphing rational functions. And technically, we could have any polynomial on the top and any polynomial on the bottom. But for this course, they almost exclusively restrict it to parabolas and lines. So you might have a parabola on the top, a line on the top, a constant on the top, divided by a parabola on the bottom, line on the bottom, constant on the bottom. Sometimes they put an x cubed on the top, but then something cancels out with the bottom. So it's not super crazy that way. And there's a bunch of characteristics of these graphs. We already looked at the three groups. One group where the degree was bigger in the numerator. Second group was where the degree was the same on the top and the bottom. And the third group where the degree was bigger on the bottom. So those are still going to be our three main groups that we're going to graph. But we're going to look at characteristics that come up in each of those. So you can take out your highlighter. Our first characteristic that we're going to look at, and that it's going to be really important, is non-permissible values. And you can make a note here. There are going to be one of two things. Each non-permissible value is either going to be a whole or a vertical asymptote. And we have to figure out when do we have each one. How do we determine if something is a whole? How do we determine if something's going to be a vertical asymptote? So this first example they give us here is x plus 3, that's a line, over, and it's already factored, x minus 3, x plus 1. So we have a parabola on the bottom. This would be group 3, where the degree is bigger on the bottom. And you have two non-permissible values. X can't equal 3, and x can't equal negative 1. Well, I'm just going to make a note here. Sometimes they call a whole a point of discontinuity. Just if you see that on the exam, I often like to write the word whole because it's only 4 letters. Point of discontinuity is like a whole English essay for me. So, but on the exam, if you've never seen it before, you get scared. It's like, oh, that's 3 words in a row. So just, that means the same thing. And we're going to look at, well, what is a whole in a graph? When does it occur? And when does it happen? Okay? So basically, what's going to happen is you're going to find your non-permissible values. And if your non-permissible values simplify away, they will appear as wholes. And we saw this in the activity yesterday. But if they stay, like in this example is going to end up with 2 vertical asymptotes. You can label them. One would be here at x equals 3, and one would be here at x equals negative 1. But if that non-permissible value can simplify after factoring, so in the second example that they have in your textbook here, you'd be like, hey, it's factored, these factors are identical, they can simplify, and I would get a new equation, which is y equals x plus 1. But I still have a non-permissible value of 3. So when that equation was simplified as x plus 1, you know that that is a straight line, but now we have to add a whole at the non-permissible value. So if the non-permissible value simplifies and goes away, it will result in a whole, because the original graph still, or the original equation still had a non-permissible value. Even if you simplify it, that doesn't make that non-permissible value go away later on. Does that make sense? To find the non-permissible value, you say, well, if x plus 1 didn't have a whole, I would have the point 3, comma, I plug in 3, be 3, comma 4. Who's seating by? Where was it? Mohammed, you're right there. Second one. Yeah. Okay? If you're someone who forgets things, this is something that students often forget. How do I find the coordinates of the hole? Well, it's really simple. If that hole wasn't there, if you had just graphed y equals x plus 1, you would have the point 3 comma 4. But 3 is your non-permissible value, so that's where your hole is. Your hole is at 3 comma 4 as a result. Here's an interesting situation. I don't know if they gave you, I don't know if you got this graph on yours. Oh, they gave you the equation, but they didn't give you the graph. Okay? If you had this parabola over this cubic, this x minus 3 would cancel out with one of the x minus 3's on the bottom. Normally, non-permissible values that cancel out become holes, but the non-permissible value canceled out but did not go away. There's still a non-permissible value of x equals 3 left on the bottom. So that would mean no holes. This graph and that graph are identical. Nothing new would appear there. So you only get a hole if a factor simplifies, a non-permissible value goes away in the simplified equation. That makes it appear as a whole. So, characteristic number 1, and we're going to put all of our characteristics together. Non-permissible values will either result in vertical asymptotes or holes. And we're going to go to example 1 here. And in example 1, maybe you have room, let's see. Maybe you have room on page 106. There's a lot of space there. To write this down, I'll give you some time. This is everything. The non-permissible values, step number 2, is what we looked at so far. We'll look at the characteristics of horizontal and oblique asymptotes, step number 3. We'll talk about finding intercepts and nice points and drawing our graph. We'll do that already in our first equations here. So now that you've written this down, I'm going to take it, make it a little bit smaller, move it off to the side, and we're going to add, it says we're going to graph. We're going to graph this ourselves. One of the things the textbook does is it introduces you to the different characteristics and then tries to ask specific questions about them. What we're going to do is we're going to look at holistically the big idea, which is, can you graph these without a calculator and all the steps? And we'll do that each time all the way through. You'll get to know the characteristics, but you'll also get really good at graphing as well. Okay? So, anytime you have a rational function, it's going to be very important that you factor. So for the first graph here, I can start by noticing the top is a difference of squares. And after I've graphed it, and after I've factored it, I'm going to list my non-permissible values. And after you've listed your non-permissible value, you have to decide if it's going to be a hole or a vertical asymptote. Does the x plus 5 simplify and go away? Yes. In fact, that x plus 5 is going to simplify. You get a new equation, which is y equals x minus 5. I wrote that in green because I have a note on our thing. If there's a hole, you graph the simplified equation and add the hole. So our non-permissible value is going to be a hole, and that hole is going to be at negative 5 comma something. How do we find that something? We're going to plug in x equals negative 5 into our equation. Negative 5 minus 5 gives me negative 10. That is where my hole is. Okay? So you list your non-permissible values and determine if they're holes or vertical asymptotes. That's step 2. Note, if there is a hole, you graph the simplified equation. So now we're going to be graphing this. That is no longer a rational equation. That is a straight line. A straight line right from grade 10. You know how to graph straight lines, hopefully, from grade 10. You don't even have to do steps 3, 4, and 5 in these because you no longer have steps for graphing rational functions. It's over. It's a line. So I draw my line. What do I know about this line? I know that this line, x minus 5, I know that it has 1, 2, 3, 4, 5. I know that it has a y-intercept at 0, negative 5. I know that it has a slope of positive 1 over 1 up 1. And I know that I have to add a hole at negative 5, negative 10. On all of our graphs, whenever possible, we will always label all of our x-intercepts and all of our y-intercepts. So I also labeled the point 5, comma 0, because when x is 5, y is 0, that's my x-intercept. Now that's part of, you're going to do it for all rational graphs, but you're going to try to do that for all of your graphs whenever you're graphing. Can I easily label my x-intercepts? Then I should label them. Can I easily label my y-intercepts? Then I should label them. There are a number of graphs this year that require you to always label x-intercepts and y-intercepts. I could give you a specific list of 7 of them to memorize, or you could just practice always labeling x-intercepts and y-intercepts and realizing if it is a situation where your x-intercept is 2 log 3 divided by log 7 plus 4, probably that was one where you didn't have to label it. Logic. But if the x-intercept is something that's nice, like 5, comma 0, absolutely. Draw it, label it, find it correctly. Okay. So that is all that we have to do for graph A. It's straightforward. It ends up being a line. You now can forget about all the other steps for rational functions because you know how to graph a line. I can make another one where it ends up being a parabola. And then you would graph your parabola, add the hole. So you might get something that simplifies into something you already know how to graph, and you would just have to add a hole. I can make one of these combined with a log. Ooh, maybe I should do that on your take-home marks. No? You're okay? You're okay? I can make a log graph with a hole in it. That could be interesting. Well, I'm really tempted. Okay, we'll see. We'll see if that ends up being on. There's room on the last page. Maybe I'll add that in. Okay. So, part B. Same thing. We start by factoring. The top, I can actually factor out a common factor of 2, leaving me with 2x plus 1 over x minus 2. My non-permissible value, x can't equal 2. Does it simplify? The only way a factor simplifies is if you have the identical factor on the top. And so it does not. That tells us that the x equals the non-permissible value will be, are you okay with that abbreviation for vertical asymptote? You're going to have a vertical asymptote at x equals 2. Asymptotes have an equation. Equation, you see the word write an equation? That has an equal sign. So the non-permissible value we write with x can't equal 2. An asymptote is an equation. We always write the equation of a vertical line is x equals, and in this case it's x equals 2. And sometimes as I'm going through the steps, I start, and I like to take out a red pen. If you have a red pen, use a red pen for your asymptotes. Bottom line at x equals 2. This is what I know so far. Okay? So as far as steps go, I've done factoring and listed my non-permissible values and determined it was a vertical asymptote. Next, step 3, other asymptotes. Okay? Do you see that this equation is a line on the top and a line on the bottom? This is group 2. What did we decide about group 2? Group 2 had horizontal asymptotes. And you can ignore everything except for the highest degree. If I take 4x divided by x, I am going to have a horizontal asymptote at y equals 4. I add that to my graph. We don't know what an oblique asymptote is yet. This one does not have one. Group 2 doesn't have oblique asymptotes. In our example the other day, we found out only group 1 had oblique asymptotes with a parabola over a line, and not all the time, only when there wasn't a hole. Okay, so step 4 is draw all of your intercepts. Okay, I always like to start off with my y-intercept because it's really easy to find. You plug in 0 for x. I often go back to my original equation. Can you see that if you plugged in 0 for x, those two highlighted things would be 0? And you would just end up with plus 2 over minus 2, which is minus 1. So I can go to my graph, and I can label 0, minus 1. X-intercept. You find an x-intercept by plugging in 0 for y. Now, I'm going to plug in 0 for y. I'm going to keep the factored version here. Okay? And the shortcut is to say, if a fraction is equal to 0, the only way a fraction can ever equal 0 is if your numerator equals 0. That's logic. You cannot have, try to think of a fraction that's equal to 0 where your numerator is not equal to 0. Right? Is 5 over 7 equal? No, that's not equal to 0. Right? 1 over a million is close, but it's not equal to 0. The only way a fraction can equal 0 is if you have a 0 in your numerator. Someone says, what about a 0 in your denominator? That's not allowed, right? We're not allowed to divide by 0. That's our non-permissible value thing. Okay? The long way is you actually, so for the most part, I actually don't set up this equation. I sort of just do it in my head. I just solve when is the top equal to 0. That's going to be, this is my only factor. Can you see that that happens at negative 1/2? If you were factoring and solving a question, you had 2x plus 1. What makes this 0? Negative 1/2. Okay? You could have technically multiplied both sides by x minus 2 to cancel out the bottom. This is algebra. And what would happen on the other side when you multiply x minus 2 times 0? You would still have 0. So all we have to do is solve where our numerator is equal to 0. And now I can plug that point in. -1/2, comma 0. And I have 2 points. Okay? Now, step 4 and 5 here says, do your intercepts, we've done that, and nice points, and it says 1 point in each section. And I'm going to describe that your vertical asymptote splits your graph up into sections. I have section 1 to the left of x equals -2, and section 2 to the right of x equals 2. And if you have points in a section, you can go right away and draw your graph towards your asymptotes. So what do I know here? I know that I have these 2 points. I want blue. I feel like drawing in blue. This is going to go towards the asymptote there. This is going to go towards the asymptote there. If you have a point in a section, you can draw the graph towards the asymptotes. Section 2, we have no points. So you just do a table of values. You can pick 3, 4, 5. You can pick anything you want. Right? Let's say you picked 3. Somebody else picked 4. You only have to do 1. Somebody picked 3. Look at your equation, your original equation. If you plug in 3, can you see that the top would be 12 plus 2, 14? And the bottom would be 1? So if I plugged in 3, 14 over 1 is 14. Somebody else plugs in 4. If I plugged in 4, the bottom would be 2. The top would be 16 plus 2, 18. Divided by 2 would be 9. So I could either graph, 4 comma 9 would be about there. 3 comma 14 would probably be about there. Ooh, that almost looks like pi. And as soon as you have a single point in a section, like if you just graph 4 comma 9, this is enough. Draw towards the asymptote, towards the asymptotes. Done. Okay? Do not be sloppy. Okay? Here is there's E10 asymptote errors. I'll draw them in orange. Right? I could get an E10 asymptote error by doing this and accidentally going through my asymptote just because I wasn't paying attention at the end of the question, or I was being a little sloppy. You can lose an E10 asymptote for going through. You can lose an E10 asymptote for getting close to your asymptote and at the end veering back away from it. Asymptotes are there to show that your graph keeps getting closer and closer to it. So if you get closer and then veer away, that's another E10 error. So as you approach your asymptote, you cannot go through it. As you approach your asymptote, you shouldn't get closer and then get further away. Sometimes we get a little sloppy at the end of graphs because we're like, oh, I'm done. My arm just flares off to the end. We have to be careful. Okay? So, this graph introduced our horizontal asymptotes like before. It also made us do our intercepts, and we had to do a nice point. Some graphs, you will have, like this one, we had to do one extra point. Plug in something to find a point, and then you could graph in that section. Some graphs, you don't have to do any extra nice points. Your x-intercept and y-intercept will be enough. And some graphs, you might have to do 3, 4, 5 extra nice points before you figure out what the heck is going on. So it's a little bit of a variable how many extra points you have, but you will need 1 point in each section so that you can draw your graph towards the asymptotes. Okay, question for practice, just circle number 5.